All right, I think we're gonna get started here. If you're having any troubles in the back, today's gonna be fairly simple. You can go just run it on your own, anyways. So just going through some logistics stuff. Course links here. Course announcements. Enrollment has been fixed. So if you were having trouble using your permission number last week, you can go ahead and try it again. We didn't have any problems recently. If you do have any more problems, please talk to us. Yeah, we've had one request for that separately. But again, just come talk to us after class or email us. You know all of our emails. Mine's up here. So the PISA one that we signed last week, there were only 30 submissions. So I think some people just didn't know that we had this problem set. So it's been extended to 2:15. It should really take you no more than like 30 minutes at like worst case to actually do it, because most of it's just Googleable.
Yeah, I'm going to be making a note about this on PISA just to remind people, let them know of the extension, just tell them to check it in too.
Yeah, there's a few people who also made Gradescope accounts and didn't submit anything, so just submit. Just make sure you've submitted, make sure everything works. And we'll get some scores out for that fairly soon after that. As a note, there's no homework for this week because we are not doing anything crazy intensive, and we'll have our first like non-optional lecture this Wednesday. But yeah, we will have a homework next week, and I think we'll assign the project next week as well, the first project. So look out for that. Office hours are pretty much the same, except for Hamza has updated his for 5 to 6. They were previously 5:30 to 6:30 on Mondays. So just take note of that. Again, all emails are up here. And then commands to run in the terminal. So make sure that you go into your make sure that you go to the Kaggle Directory git pull, because I've uploaded a few things. And then you'll want to start your Docker. And oh wait, this kind of formatted weird. Oh, I guess I just formatted weird because of the screen size. But yeah, make sure you're just on the regular screen here. If you want to open up the slides, they're already linked in the repo. And then you should be good to go. So today's lecture is going to be on data visualization. Now, I'm not really going to focus on these slides too much because I'd rather go through the IPython notebooks, which you can use for future reference for your projects, where you'll have to be making like charts and stuff like that when you're doing your initial data exploration. So data visualization is really nice for doing just general data science stuff because it gives you an idea of what the data looks like. So let me pull up the, oops, 70 moment. So yeah, I'm going to start my Docker container. You can follow along if you'd like. So copy the command. Oh, oops. Oh, what's happening? Sorry about that. I'm having some problems with my Docker. If you do have any and you're on Mac, you can usually just restart it and most problems go away. All right, for now, I'm just going to make, just going to do this in a regular Jupyter notebook. Should work the same. If you have any problems that may occur because of different ways of loading Jupyter, then just let us know. Hamza will help you out. Raise your hand. Cool. So go to day 3 and go to data viz for the first notebook that we're going to be running through. So this right here is a notebook that goes through data visualization specifically for the Titanic dataset, which is kind of like a classic competition on Kaggle. So it's one of those open competitions that they just keep running for the length of Kaggle, I guess. And you can just go in and you can go and predict which people may have survived and may have died during the Titanic disaster. And so if you remember, or if you've like watched the Titanic movie, or if you've like heard some stories about it, there were some key details about like who would survive and who wouldn't survive. A lot of the times what would happen is men were told to stay on board and women and children were brought off. But oftentimes there was also a separation between like those who were lower class, who happened to be in like the lower floors and thus could not get to the top of the Titanic fast enough, as well as those who were in the upper class who were at the upper floors. And those people were more likely to survive. So basically, the goal of this notebook is to just demonstrate how we can use our data science visualization skills to see what kind of disparities there are in the data, and then later on, what we could do is use this information to build a better classifier to determine whether or not somebody survived, or better classifier more generally, just like for whatever task we have ahead of us. So the first thing you'll probably want to do is run this command here. I imagine all of you don't have stats model or patsy installed in your Docker container, so you'll just want to do this pip install here. If you have any problems, I think you can run something like conda install with the same packages afterwards. So yeah, but you should be good if you can run this and it doesn't throw any errors. Cool. Anybody have any problems? Yeah? Oh, is it just a warning?
Yeah.
So anytime you get a warning, that's usually fine. That's some leftover stuff from Matplotlib's library, so you should be good. Yeah,
When I try to pull, it says please commit your changes before merging.
Oh, what you should do is just git add -- all, and then git commit and write something. Yeah. So you can commit and you'll have a local copy, but you won't be able to push to the directory that we have unless you made your own. Then you can push to that remote.
Git commit dash add.
Yeah, as long as you add everything, it's the same. Yeah. Yeah, I can tell you about that later. But yeah, there was another problem here. Okay, cool. I think we're set. Raise your hand periodically, and Hamza can try to help you. So the first thing we're going to do is load the data set. So we're using a package called pandas, which basically allows you to do some very nice data set formatting. So what this read CSV does is it basically takes the CSV file, which is located in the datasets directory, and it'll basically load it as a data frame. And a data frame just looks like this. There's basically these columns with their specific names. So as you can see here, there's like passenger ID, the number, whether they survived or not, which is the 0 or 1 category. The class that they're in, so this is like the one that would best correlate with their economic status. And then their name, what gender they are, their age, and so on. So all these features right here. Now you can see, first of all, that there's a few of them that have some problems. So this right here, there's some NaNs, which means not a number. Basically, it means that there's no entry for that specific entry of this data frame or data set more generally. And so that'll become apparent if we try to run numerical analysis. If we try to use like a not a number inside of our analysis, it'll throw an error. And so what we can do with this is actually determine some other cool statistics about what's happening here. So we can use the method from NumPy called Unique, which basically allows you to check what are the unique values. So one of the things we could check out are like what are the different types of classes there are. So we can pretty clearly see that there's 3 classes just displayed on the screen right here. But if we want to know every single unique one, we could just run mp.unique and we see it's just 1, 2, 3. So pretty simple. Maybe we could do something a little bit more complicated and look at, let's see, where people have embarked from. So there's more description about this on the Kaggle website. Kaggle Titanic. If you look up Kaggle Titanic dataset, then you can find this link right here. But if you want to go into more details, but basically embarked means the city that they embarked on for this journey. I don't remember exactly what the specific locations are, but they're all just from the UK. Oops, what happened here? Oh, as a note, so you can basically index a column from a Panda data frame by just grabbing, it's like a dictionary indexing. So you basically use like the brackets, you pass in a string, and it'll grab out that specific column. So, let's see. As you can see here, we have our, we have all the outputs from embarked. I think I may be mistaken on this mp.unique. Yeah, okay, my bad. So mp.unique only works on numerical data, so what I was trying to do there is pass in some strings. Now, there's a method to quickly convert that to a like numerical number, but I don't remember it off the top of my head. So let's just keep going on with this notebook. So the first thing we want to do is somehow deal with these not a number values, and Pandas gives us a nice quick shortcut to mess with this. So first thing we're going to do is remove the ticket and cabin columns because those turn out to have a lot of NaN numbers. And so those won't really add a lot of information to our analysis, and so we're going to just remove them. So the shortcut is just basically df.drop, and then you pass in the column names as a list. And you have to set axis as 1 because you want to remove it from the columns rather than the rows. Axis equals 0 is the rows. So basically the entries of the data set. And then what we do after that is we do drop NA. And drop NA basically takes all of the rows that have an NA value. So it doesn't matter which column actually has the NA value, the not a number value. It'll remove that entire row as long as any entry has that. So if you look back here, we have df drop, and there should be no not a number values here. Just from our quick scan. Cool. And so now we want to explore our data graphically. And so this cell right here just basically outputs a shit ton of really cool subplots that you can use in your projects. And it takes a second to load. But as you can see here, we have our distributions of how many people survived versus died. So you can see that a lot more people died than actually survived. Something in the order of like 500 something actually perished during the tragedy. And then here's a simple like stack plot. As you can see, it doesn't really make sense to have continuous values here because people either survived or died based on their age. So it's kind of a weird plot. And yeah, everything else here is pretty interesting as well. So if you want to go look through the code and just figure out which specific plot goes for which specific like output, or sorry, which specific code block goes with each specific output, I'm pretty sure they're well labeled. At least like you can just tell by the titles that they set. So plt.title, and then they'll add it in as a part of the subplot here. So this right here is with the class distribution, basically this plot right here. So if you remember, just from above, what we basically did was we dropped the ticket and cabin, the cabin rows. But what we also did was we dropped all the NA values. But instead of doing that, we would okay, I'll take a step back. So when we drop the NA values, we lose a lot of rows, we lose a lot of data points, and we lose a lot of this extra information that would be otherwise encoded in the NA values rows. What's up?
So when we drop and we lose like an entire row.
Yeah. So actually, we can show. I can show you the links before and after. So we have len of df drop, and then len of df. So you can see that we dropped like 170 rows here, and so that could be very valuable data, even though that those specific like columns may be missing some information. And so what we can do instead of dropping is actually just fill in the NA values with a 0. So while it may still kind of affect our classifier, we still preserve this other information, and our classifier may just choose to weight this lower during the learning algorithm step. But the nice thing is with assigning it a 0 value, it has like pretty low impact on how the classifier actually runs. So if we run that, it should be all silent. And if we look, if we do the analysis that we did for the past one, we can see that the size of the data frame doesn't change anymore. It's the same as the original data frame. So we preserve whatever information we lost. Whatever information we had lost previously. And so if we plot this again, we actually can see that the results are fairly similar. Not much has changed, but maybe the distributions have slightly shifted. Yeah, no, but the changes aren't terribly noticeable. So it seems like if we had kept it or dropped those, it wouldn't have changed these statistics that much. Now in other data sets, that may be much more important. So now what we want to do if we're like actually engaging in a regular competition, or if we are trying to do like a regular application of a machine learning algorithm, is we probably want to figure out what features are more important than the others. And so one of them, what we could do is basically just look at every single feature and just see, oh wait, what is this for? df.survive. Okay, yeah, so never mind. So this first part just demonstrates the number of people who died and survived. It's the same thing as this plot up here, so not as interesting. But now what we can do is see how different categories of gender, as well as class, break down when we plot them together. So I mentioned earlier that, ooh, wow, this looks cool. Oh, okay. So here we first see the breakdown of gender of people who died and people who survived. So as you can see here, many more who survived with respect to gender. I'm not sure about this right side, but basically you can see here that about 50% of the females died. I mean, 50% of the people who survived were female, and 50% were male. But as you can see here, a higher portion of the people who died were actually male. So now we can compare the gender and the classes. So again, I'm not really going to go over these too much, but I'll go over this real quick. So there's df.survived right here. This basically just says we want to grab all of the females who survived, and their class is not equal to 3. Basically, they're all like upper class or high class. And then we have another query that will grab all the ones that are considered low class, so where their class is equal to 3. And then we can construct some histograms that compare the two of them. So we have our survived ratio here. We see that females in the high class were almost all survived. So maybe there's a few outliers here and there that actually ended up dying because of some weird reasons. But you could see with the female low class, it was pretty much 50-50. As you can expect, it's probably a condition of like who was rejected from getting on lifeboats, or who got stuck stuck in the lower decks or something like that. Additionally, you can see the disparity of the number of men who died in the low class. So pretty much this bar chart is maxed out here, and you can see just a huge number of lower class men died, while a comparably smaller amount of high class men died, and a good number of them survived actually. Let's see. So I'm not sure what this one does. Okay, so now this last plot basically just combines everything together and just compares like the distributions between the different categories we throw everything in. So this first one's just regular distribution of deaths versus people survived. This is the distribution with respect to the gender. And then this is the distributions with respect to gender and class. So that's pretty much it for this first part, I guess. The next part of this notebook is basically just running through some machine learning algorithm called Logistic Regression. We'll get to this next week, but if you want to just run through it really quickly, I can just like run all these right here. So these are a little bit confusing to look at right now because you're not familiar with the algorithm, and they're basically just results of how well it calculates or it classifies the algorithm. Classifies the data, classifies the like survival rate based on the data. And then here's some graphs that are also kind of confusing if you've never seen them before. I actually find them still pretty confusing, but they just kind of would give you an idea of like how well your classification did. So this is comparing the ratio of predicted survivals based on gender. So if they're like a male, then they're less likely to survive as you'd expect, and then female, they're more likely to survive. So that's pretty much it for this notebook. This other one pretty much goes over a similar topic, but it goes into more depth with let me see. It goes into more depth with things like Seabourn, which is another kind of package that allows you to visualize data very nicely, and it looks a little bit better than Matplotlib in my personal opinion. You can see, whoa, oh my bad. Just run this real quick. So as you can see here, it's just like looks slightly better. Really choosing either one is up to you. Just make sure that you have it installed whenever you use it. But I think this graph, I wish it was better. Yeah, this graph is a pretty good demonstration of things you can do with Seabourn. I think it looks pretty good. So this is the distribution of where people embarked and the sex, age, and where they embarked. So male and female are represented by the colors of the graph. The age is represented by the height, or the y-axis, and embarked is represented by these histogram positions here. And then additionally, we can see which data is missing through this graphical interpretation with missing no. So as we mentioned before, cabin was pretty low distribution of missing values, as well as age had some missing values as well. So you can see that there's like these empty lines here that just demonstrate which data points don't have values for them, and they would appear as NAs in the data set. Does anybody have any questions? Yeah, that's pretty much all we had planned for today. So today was meant to be quick. Yeah, do you have this one right here? So if you remember from this cell right up here, we had to drop some NA values, right? Or we had to fill them in with NA values. And so what this visualization basically does, it just allows you to see which values are actually missing. So you can yeah, the white color is basically missing value. All the gray means that each cell or each row has a value for that feature. Yeah, yeah, yeah. Okay. You can't seem to read any of the CSV files. You're in a Docker. Are you in a Docker container? Do you know where you entered in the Docker container? So the best place to run it is the root directory of the Kaggle Decal thing. So in SP17, basically, that folder, that's the best place to run it because you need access to the data sets. Otherwise, it'll have some problems. So you can just like close it and then rerun it from.
Probably gonna go.
Oh yeah, I don't even know the status of that honestly. I haven't been there.
Yeah.
Okay. I think that should be fine. So